what we're doing are counting problems. Don't mind your Okay, anyways. So we are doing counting. So the idea with counting is, Jacob, take a seat. The idea with counting is we're trying to find the number of ways something can happen. Yes. Okay, so let's start with a basic, we're going to toss a coin that has heads or tails on it 3 times.
I can actually do it like that.
No, stop. Just pay attention, please. So yes, some of your calculators can simulate some of this stuff. That's fine. But we want to find the number of theoretical ways something that can happen. So we're going to start our event. Now we can draw a tree. So this is going to be a tree diagram of the events. This is our starting point, so don't get confused, you have to start somewhere. And we have 2 branches, right? So this is the first toss 1. And we could get heads or tails, you see what I'm doing? And then after we toss the first time, we have the second toss. Well, maybe I had heads, and then I toss a second time, I could get heads or tails, you see what I'm doing? But maybe on the first toss I got tails, and on the second toss I could get heads or tails. And then we have a third toss 3, and maybe I got heads, and then maybe I get heads or tails. You see what I'm doing? And I'm just branching off for each of these, heads or tails, heads or tails, and then heads or tails. And what this tree diagram is going to show me is going to show me all the possibilities. And it does show me the total number of outcomes. If I look at the far right, I see that there are 8 possible ways that this could happen. Now I might have a question here. Is this event, heads, tails, heads, is that different than this event, tails, heads, heads, heads?
No.
Okay, so in both cases, see, this would be, the order is different, right?
Order the same thing.
Order is different. And so that's gonna be part of our discussion today, is when does order matter and when does it not matter? Well, in the case of successive coin tosses, if I'm trying to determine, who's going to play and who's not going to play, then the order is going to matter because, this person does play, that person doesn't, that person plays, that sort of thing. So, whatever. Let's do another tree diagram. So, suppose that Kevin is buying a car. But he doesn't want to talk to the salesman, so he buys a car online. Okay, so please listen. So he's buying a car online, and he's on the form. It's going to ask him some questions. So it might ask him like for the exterior color, right? Mm-hmm. And they're going to give him every possible option. He might have like red as a choice. He might have black as a choice as a common car color. He might have blue as a choice. So he might have those car choices for the model that he has selected. And then they might say, well, interior material. So what does he want for
leather cloth, or vinyl?
Okay, yep, those are typical options. And for our case, for his interior material, we're going to say that he could have a leather car or a cloth. No vinyl for this one. Whatever. Okay, and then of course he's most concerned with this option, the radio selection. He could get a standard AM/FM.
Series.
He could get the navigation system. which includes the radio, or he could get that Sirius XM model. So maybe those are his options, and maybe he could then maybe have a CD player option, the CD FM radio. So he has those 4 options. So what do we want to do? We want to find the number of possible cars that he could select based upon this model. Okay, so we see here that he has 3 choices for color, he has 2 choices for material, and he has 4 choices for radio. So the first way to find the possibilities is called the multiplication principle. Which says that I'm going to be able to multiply each separate thing. So I could do 3 times 2 times 4, and that will give me 24 possible cars. So I just multiply all the things.
That seems like the easiest. Now, Mr. Payne, didn't we learn something where we did something with an exclamation point?
Yes, and we're getting to that shortly. Okay, so let's go ahead and draw our tree diagram for that. So we're going to start here, and he could have a red car, he could have a black car, and he could have a blue car. Okay, so this would be the color choices. And then we have what was our next choice? Our material, right?
Yeah, weather. Well,
material. And after he chooses red, maybe he chooses cloth or leather, cloth or leather, cloth or leather. And then after that, he picks his radio. And how many choices did we have for that?
3, 4.
4. We had our FM, and I'm not going to write out all of these. We had our XM radio. We had our navigation system radio, which is basically the all-inclusive, has everything. And then we had the CD player option. All right, and then you see we would have all of those on each of these. Do you see what I'm saying?
Mm-hmm.
So that would show us all 24 possibilities.
And then you just count up how many things you have?
How would you out that and not necessarily? You'd have to spread it out a lot.
Okay. All right. So let's do another situation where we have multiple things that we would select. So let's say we are choosing outfits.
For prom.
And maybe we have 3 types of pants. Maybe we have 2 types of shoes. Maybe we have 5 types of shirts. Maybe we have 6 what? I don't know.
Ties.
6 ties. There we go. 6 ties. All right. So how many outfits are possible?
I would say multiplying by
Yeah.
180. Range of 180.
He's right.
Now, Mr. Payne, will we be mandated to do the tree way? Or can we do it the multiplication way?
So we do 3 times 2 times 5 times 6. I heard you, but was busy at the moment. So we could do the multiplication way. So we have then 6 times 5 times 6. So that would be 30 times 6, which is 180 possible ways. So you can see why we wouldn't have wanted to do a table for, or the listing for all those, because that would be 180. Yes.
We don't have enough paper.
Okay. Let's do the next thing, which is going to be choosing a password.
Oh, yeah.
Okay, so we're going to choose a password. It may be, sure, it's 8 digits. So we're going to choose a password that has 8 characters, we'll call them, and is made of only numbers. Okay, so 8 characters, so we have an 8-character password. So we might set it up like this, and then we would say, all right, so I have 8 possibilities here. How many digits, how many numbers do I have to choose from? Well, 10. Okay, 0 through 9,
0.
so we have 10. So for each one of these spots for my password, I have 10 possibilities. What do you think I'll do with these 10s? I'd multiply them. So I get 10 to the 8th is going to be a rather large number. So we'll just write it like that.
That's quite a few.
I got 100 million.
Okay. Now let's do this next thing. Let's extend this idea of a password. We'll say 8 characters with only lowercase letters.
Still 8 digits.
And it's 8 characters. Okay, could you please look up here, please? 8 characters. So we have 4 of them there, 4 of them here. So a total of 8. How many letters are there?
26.
Okay, so we have 26 letters in the alphabet. So we have 26 possibilities for each one of these. So we aren't going to put this in our calculator and get an actual number because it's going to be rather large. So 26 to the 8, all right, would be our answer there. Now, suppose I'm doing an 8-character password, but no repeats. I'm not going to allow any repeats
10
at
times
all.
9 times 8 times.
Yeah, so we're getting there. And only, once again, letters. Lowercase. So we have 8 of these. And I start with 26, but then I will have used one.
So 25.
So then on the next one, I have one less, because I can't use it again. 24, 23, 22, 21, 20, and 19. So let me ask this question. Does order in a password matter?
Yes, because if you don't remember the order, then you're not going to get a right password.
Right. So the answer is yes, order matters. And whenever order matters, that's called a permutation. Whenever order matters, that's a permutation. So notice we had 8 characters, right? 8 characters that we were selecting. So, we could multiply those all out, and we would get that, get our answer. A permutation, oops, I wanted to simply add. A permutation is written like this, NPR, which is n factorial over n minus r factorial. well, what is this factorial thing? Well, first of all, before we get to that, let's set this up. So I had n is the number of possible objects. And r is the number I want, number I'm allowed to choose. So in this case, I had 26 possible letters to choose from. I'm going to permute 8 of them from that one that we just selected. And when I put this in the formula, I get 26 factorial over 26 minus 8 factorial, which then is going to be 26 factorial over, what's 26 minus 8? It's 26 minus 8. Over 18 factorial. But what does this mean?
Well, I know what you would end up doing. Well, that would be 26 and 25 and 24 all the way down to 1.
Right.
That's what little extra.
Right. So that's correct. So factorial. So factorial means multiply down to 1. So if I had 6 factorial, that means 6 times 5 times 4 times 3 times 2 times 1. And if I had 6 factorial over 4 factorial, for some reason, what I would do is I would write 6 times 5, but then right here I'd stop at 4 and I'd say, well, the rest is 4 factorial. And then at the bottom I have 4 factorial, because what does this 4 factorial mean? 4 times 3 times 2 times 1. And this one would mean 4 times 3 times 2 times 1. So what would I do? Well, I could just cancel those and I get 30. So there's no reason to jump to a calculator and start putting that in. We might introduce rounding errors if we had a lot of additional questions. What if I had 11 factorial over 6 factorial, 9 factorial? Well, let's see how we could reduce this. So I'm going to count this 11 down to the 9. So 11 times 10 times 9 factorial. So the 9 factorials are going to cancel. And then the 6 factorial, I'm going to write that out. 6 times 5 times 4 times 3 times 2 times 1. And I'm going to see what cancels. Well, 5 and 2 equal 10, right? So that will cancel to 10. So I'm left with 11 over 6 times 4 times 3 times 1. Oops, I wrote a 3 when I meant a 4. Do you see how I did that? And then I have 11 over, well, what's 6 times 4 times 3 times 1?
72.
And there we go. All right, we'll do one more, and then we'll call that for our notes today. So let's go back to that problem we did. We had 26 permute 8, right? And then we put that into our formula. Our formula for permutation is n factorial over n minus r factorial. So that's going to be 26 factorial over 26 minus 8 factorial, which someone had said was 18 factorial. Now we're going to count down this 26 down to 18.
Because there's no reason to go past that.
Right.
No reason whatsoever. We'd just be shooting ourselves in the foot.
The 18 factorials will do what?
Cancel.
They'll cancel. And we see exactly what we had originally, right?
Yes.
So you might wonder, well, why don't I just always jump to there? Well, sometimes the situations, especially when we're doing probability, are not going to allow us. Okay, so we'll continue this discussion tomorrow.
Bye-bye. Like and subscribe. Check out mcanc.com for the latest.
Do you appreciate it?
Slap.